Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, welcome you all to this another session on the UV visible spectroscopy. Today we are going to discuss about the one of the important part of UV spectroscopy is Woodward Fieser rule. This particular rule is used to calculate the lambda max of given compound by observing its molecular structure. This rule was first developed by Woodward. This is the name of the scientist, and certain modifications are made by the Fieser. That's why this rule is commonly known as the Woodward Fieser rule. Now let's see what is that Woodward Fieser rule. Before that, we will see what are the learning outcomes of this session. After this session, students will be able to explain or calculate the lambda max of Dienes, Trines, Paulins structure from their molecular structure. Now, whatever this Woodward Fieser rule is there, this Woodward Fieser rule is applied to two different sets of the compounds. One set is Dienes, Trines and Paulin substances, and the second set is the carbonyl compounds. Today we are going to discuss about the Dienes, Trines and Paulins only. Regarding the carbonyl compounds, we will discuss that in the another video. So before starting with the Woodward Fieser rule, we should know certain definition. First definition that you should know is homoannular diene. Now what is the meaning of homoannular diene? Now we know diene means what? If two double bonds, if they are conjugated, it is known as the diene. Now homoannular diene means what? It is a cyclic diene having double bonds in the same ring. Means whatever two double bonds are there which are the part of the diene, these both the double bonds are present in the same ring. In that case it is known as the homoannular diene. Homo means same. By observing these structures you can identify easily what is the meaning of homoannular diene. Now here you can see, here this compound is having three double bonds, so this is known as the trine. So if we consider these two double bonds, then it is known as the diene. These both the double bonds, as they are present in the same ring, it is known as the homoannular diene. Here also you can see this particular ring is having two double bonds. As these two double bonds are present in the same ring, it is known as the homoannular diene. Then next definition is heteroannular diene. What is the meaning of heteroannular diene? Like our homoannular diene, the double bonds that are involved in this particular case, these double bonds are present in the different ring. For example, here you can see, now this is the first example. This is considered as a diene because you can say this is a conjugated diene. Now what is the meaning of conjugation? If we move from this carbon atom to this carbon atom, here you can see double bond is present. After this double bond, this single bond is present, and after that immediately there is a presence of the double bond. In that case only this particular compound is known as the heteroannular diene, because whatever double bonds that are present, both the double bonds must be in the conjugated form. Suppose if we shift this double bond from this position to this position, that particular molecule does not becomes the heteroannular diene because it is not a conjugated, that will be unconjugated diene will be there. So we have to make sure that whatever compound is there, that compound must be a conjugated diene. Similarly, you can see here also in this particular example, here there is a presence of double bond. single bond and again double bond. So here also two double bonds that are involved in the diene, they are present in the different ring. That's why this is known as the heteroannular diene. Further, here also you can see these two double bonds are present in the different ring. That's why it is known as the heteroannular diene. So basic difference between the homoannular diene and heteroannular diene is, in homoannular diene, double bonds are present within the same ring, and in case of heteroannular diene, double bonds are present in the two different rings. But condition is that they must be in the conjugated form. Further, next definition that we are going to discuss is endocyclic double bond. Now, there are also two different types of the double bonds are there. Now, what is the meaning of endocyclic double bond? It is a double bond present in a ring that is shown as below. Here, if the double bond is a part of the ring, then that double bond is known as the endocyclic double bond. Means in addition to that, your diene, if double bond is present, that is known as the endocyclic double bond. Next definition that we are going to discuss is exocyclic double bond. This is about the endocyclic bond. This is about the exocyclic bond. What is the meaning of exocyclic bond? It is a double bond in which one of the double bonded atoms is a part of the ring system as shown in this polygonal structure. Here you can see this double bond is not present within the ring, but one of the carbon atom of the ring is involved in this double bond. So it is said that this is the exocyclic bond to this particular ring. Means if one of the atom in the double bond is involved and which is a part of the ring and it is involved in the double bond, then it is known as the exocyclic double bonds. Also, it is possible that in a same given structure there might be presence of endocyclic double bond as well as the exocyclic bond. Now here you can see the third structure. Here two double bonds are there. Out of that, this particular double bond is known as the endocyclic bond because it is part of the ring, while in this case only one carbon atom is a part of the ring of involved in the double bond. That's why it is known as the exocyclic bond. Similarly, here you can consider this A ring. You can consider this as A ring. This particular A ring is consisting of this endocyclic bond. Also, this is your heteroannular diene. This is also consisting of one double bond. Out of this is endocyclic to this ring. This double bond is endocyclic to this second ring. Also, this double bond is exocyclic to this A ring because here one of the carbon atom, as it is this common carbon atom is present, it is a part of this double bond and it is also part of this ring. That's why this bond is considered as a endocyclic for this B ring and exocyclic to this particular A ring. Means depending upon the position of double bond, it may be endocyclic or it may be exocyclic to the adjacent ring that is present. So these are the four definitions that we have to discuss. That is the homoannular diene, heteroannular diene, then endocyclic double bond and the exocyclic double bond. Now, by considering the examples of different compounds, Woodward and Fieser, they have postulated different values depending upon whether the substituents are present, whether the heteroannular diene is there, whether the homoannular diene is there. Depending upon, they have proposed the certain values. They have observed so many different compounds which have given the different values, and by observing the lambda max of these compounds, they have postulated these different values. Now, first we will discuss about these parent values and increments for different substituent and groups. Now remember that this table only is applicable for dienes, trienes and the polines. It is not applicable for the alpha beta unsaturated ketones, aldehydes, or the, you can say, carbonyl compounds. Now here you can see this particular table is consisting of three parts. One is the parent value, one is the increments, and third one is the oxochromes. Now parent value means what? Here we know, or we have seen, the homoannular diene, heteroannular diene. Now another type of the diene, if the compound is acyclic conjugated diene, and heteroannular diene, if they are present, we have to consider parent value as 215 nanometer. If homoannular diene is there, then that parent value is known as the 253 nanometer. Then if acyclic diene is there, remember it is not a conjugated. If acyclic diene is there, then the value is to be considered as a 245 nanometer. Now in addition to this basic value, we have to add certain increments. These increments are corresponds to the each alkyl substituent or a ring residue as a 5 nanometer. Means suppose two alkyl substitutions that if they are present on the diene, then we have to consider 5 into 2, that is we have to add increment of 10. Further, if exocyclic double bond is there, 5 nanometer. If double bond extending the conjugation, means in addition to the diene, if a third double bond is there in conjugation, then we have to add increment of the 30 nanometer. Also, if certain oxochromes like OR, that is the O alkyl group, 6 nanometer. For SR, we have to add 30 nanometer. If halogens like chlorine, bromine, if they are present, we have to have the addition of the 5 nanometer. If NR2, that is the amine functional group, if it is present, then we have to carry out the addition of the 60 nanometer. And if this OCOCH3 group is there, ester functional group, we have to carry out the addition of the 0 nanometer. Means this particular functional group does not have any change in the lambda max of that particular compound. So I request you that you should note down these particular values, because for calculating or for solving different examples you will need these particular values. So first we have to consider heteroannular diene, which is having a 215 nanometer as a wavelength, lambda max, and for homoannular diene we are having 253 nanometer as a wavelength. Now in this video we will discuss one example by using this particular table how to calculate the lambda max. Now this is your example. You have to calculate the lambda max for the 1,4-dimethyl cyclohexane 1,3 diene. So this is your example, 1,4-dimethyl cyclohexane 1,3 diene. Now if I divide this particular structure like this, here I will consider this as a your diene. So this particular part is considered as a diene. Now this particular part is also having a ring residue. If you remember in table also we have discussed, if there is a presence of the ring residue, then we have to carry out the addition of the 5 nanometer for one ring residue. Now as we see this particular structure, this is the structure of homoannular diene, because both the double bonds are present in the one ring. That's why parent value for homoannular diene we have to consider it as a 253 nanometer. Also suppose now this is the diene, this carbon atom, this carbon atom, this carbon atom, and this carbon atom, they are having, or they are the actually dienes. Now this carbon atom is having one alkyl substitution and one ring residue. Similarly this carbon atom, which is a part of the diene, is having one methyl group as a substitution and one ring residue. So for this we have to consider the value of 2 alkyl substitution and 2 ring residues. So 2 into 5, that is equal to 10. The total becomes 273 and observed value is 265. So that much calculations that are close by using this Woodward Fieser rule we can calculate for the dienes. Few examples also we will study in the next video. Before that you can use this link to solve your exercise.